Let's now look at the connection between the factor tables and the spectral densities of models with a 1 minus b to the s in the model. So we're going to look at it from the textbook's point of view here and start with s equals 4. We might do a couple more examples, but first we're just going to look at the factor table associated with a 1 minus b to the 4th. So we'll cruise over here, and a very simple way to do this is just say factor.wge, and then we want to say phi equals, and then this is just saying, hey, 1 minus b to the 4th, what is the coefficient of b? It's 0. What's the coefficient of b squared? 0. What's the coefficient of b cubed? It's 0. What's the coefficient of b to the 4th? It's 1. And so very simple way of putting those in there, and we can do it just like that. And we see that as we've seen in the past, every polynomial can be factored into irreducible degree 1 and degree 2 polynomials, this one in a unique way. So a 1 minus b to the 4th can be uniquely factored into a 1 plus b, a 1 plus b squared, and a 1 minus b. And notice they all have roots on the unit circle. It won't have explosive behavior from roots inside the unit circle. It won't be stationary. They're all non-stationary with a useful root that is on the unit circle. So just as a matter of notation that'll help us out later, it's not a big deal when it's just b to the 4th, but if I did factor.wge, I might decide to do c rep 0, 3. That's repeating 0 3 times, which is what I did here, 0, 0, 0. It was easy to type, but if we had something like b to the 12th or b to the 15th or b to the 200th, we probably don't want to type in 199 zeros. So if we do that, then you get the same factor table, just something that might be able to help. Now we want to link this to the spectral density. What does the spectral density look like for a model that has a 1 minus b? So one way we can do that here, we can't generate, well, we can generate. Let's just check that out. So in fact, let's do this. Okay, so to look at the spectral density from a model with a 1 minus b, we can just generate a realization. We'll generate it really long. So we'll say x equals, let's say x4, just to let us know it's a b to the 4th, equals gen dot arima WGE. Let's generate 1,000 observations, and let's just let s equals 4. And if we all want to, that'll be fine. However you generate it, if it's s equals 4, we'll be fine. So that's what an s equals 4 looks like, or that's one realization from an s equals 4, but what does the spectral density look like? If we looked at parsin.wge, it would have x4, and that would do something like this. And notice we see that it's got a peak at 0, a peak at 0.25, and a peak at 0.5. And if we go back to the spectral density, or go back to the factor tables, right, it's saying, hey, it's associated with a peak at 0.5, that's this one, a peak at 0.25, that's this one, and a peak at 0, which is that one. And they're all with equal magnitude. This is from a sample, so this one happens to be a little bit higher, but in reality, all of those, in the true one mathematically, those are all at 1. And that is what I like to call a signature, a spectral density signature of what a 1 minus b to the 4th is. We're going to see this in the future when we do some overfitting, so we'll plant this seed for then. But the big picture is when we have a realization that we're not sure what's in it, but we think it might have some domain knowledge, or we might have, just by looking at it, think it might have a period of 4, we might look at the spectral density of that realization and see if we don't see something that looks similar to this, a peak at 0, a peak at 0.25, which is a period 4, and a peak at 0.5. Okay, so we also mentioned, that is this one here, we also mentioned we might look at a 1 minus b to the 12th. That's one that we're going to useful a lot of times with monthly data. If you got sales data or something, a lot of times that has a period of 12. It doesn't have to. But it could. So a lot of times the s equals 12 comes up in practice, so we could do the factor.wge with 11 zeros, or we can just say, hey, let's repeat 0 11 times and put a 1 in the 12th spot. So I'm going to go ahead and grab that and come over here, and there is the factor table for a 1 minus b to the 12th. It has 7 factors, 7 degree 1 and degree 2 factors. That's unique factorization into irreducible degree 1 and degree 2 polynomials with their corresponding system frequencies. So what that means is when we look at the spectral density is a lot of what I look at the spectral density as is a visual representation of this factor table. It will have peaks at these various system frequencies. So let's look and see what we did last time. Kind of a pro tip that you may know already is just hitting the up arrow here retrieves prior inputs into RStudio. So I'm going to change that s equals 4 to s equals 12. So I'll generate 1,000 observations from a process that has 1 minus b to the 12th. And if I do that, maybe I'll change that just for completeness to 12. And I do that, and that's what it looks like for this particular realization. If you ran it, yours looks a little bit different than that. But if we do the parsin, again, I'll hit the up arrow here, parsin x12, and what we should see are